Hi, my name is Hans Deep Singh, and today I'll be performing a demonstration of Lab 1, measurement of thermal expansion and densities. Before we go over our experiment, let's go over our safety note. Safety goggles and lab coats must be worn at all times in the laboratory. As we'll be dealing with a steam generator and hot metal parts, heat-resistant gloves should be worn when dealing with steam. This experiment can be divided into two different parts. The first part studies the thermal expansion of three different metals, namely copper, aluminum, and brass. Now, most metals expand when heated, and although this expansion can be small and negligible in most cases, it can have vast impacts in chemical industrial equipments and building structures. The amount of material expands depends on the coefficient of linear expansion. This expansion will be measured using a rotary motion sensor, which will send a signal to the computer and can thus be recorded. In part 2 of the experiment, we will be determining the densities of two unknown metals, and using these observations and their results, we will try to identify these metals. Now let's take a look at the equipment that will be used in this experiment. Here we see the heat-resistant gloves, the three metal tubes, the stand for the three metal tubes. This contains the rotary motion sensor as shown over here, a retaining clip to hold the metal tubes in place, and a thermostat connected to the stand. Here we see a steam generator. The steam generator contains an electronic thermometer. Over here we have a beaker which collects the condensed steam from the steam generator, and an ice bucket. We also have an electronic caliper to measure the diameter of the pin on the rotary motion sensor, a measuring tape to measure the length of the tubes, the Pasco 850 interface. This contains the rotary motion sensor connections and the thermostat connections. Along with this, we have the computer to collect the data, and finally we have the equipment for part 2 of the experiment, which includes the graduated cylinder and the two unknown metals. Before we start the experiment, we'll make sure that the Pasco 850 interface is turned on. This can be done by the switch over here. We'll also make sure that this is connected to the computer. The Pasco Capstone software should also be turned on to be able to measure the data. Now, to begin the experiment, we're going to fill the steam generator with water. To do this, make sure you've worn your heat-resistant gloves, as the steam generator could be hot from a previous experiment. Gently open the steam generator and fill it with at least half to 3/4 of water. After making sure the seal is tight on the top, turn the switch on for the steam generator and make sure the power is on high. When the steam is not being used from the generator, make sure that the exhaust pipe is pointing inwards of a beaker. This ensures that all condensed steam is collected without any spillages. Now we'll be taking the initial measurements required for this experiment. First off, we need to find the diameter of this pinion on the rotary motion sensor. The diameter of this pinion is important because it allows us to convert the angular displacement caused by the expansion of the tubes into a linear displacement. This can be done using this electronic caliper. To use the caliper, simply press the on button, and when the clamps are fully closed, press the 0 button to ensure it's zeroed. Then slide the clamps apart and simply place them around the diameter of the pinion while sliding them until the clamps don't close any further. After that's done, simply slide it off to be able to measure the diameter of the pinion. Next, we must measure the length of the tube which will be used for this experiment. This can be done by measuring the length of the from the retaining clip closest to the end, right to the end of the pinion. For this, we must take the retaining end over here and place it into the holder right here at the end of the tube stand, as such. As you can see, the retaining clip goes well into the socket over here for the tube stand. Thus, we'll be measuring the length right from the retaining clip over here to the pinion over here. To do this, we'll be using a measuring tape. As such, we'll take the length from the pinion all the way to the end of the retaining clip. Now we move on to calibrating the thermistor. which is over right here. To do this, we must first go to our Pasco capstone program and go to calibrate. Once we have gone to calibrate and it says temperature for the type of measurement to calibrate, we can press next. Once that's done, and after making sure that we have clicked the 2 standards option, we can again click next. And now we are going to find the standard value for 0 degrees Celsius. For this, we're going to use the ice bucket over here. For calibrating it to 0 degrees Celsius, we'll take the thermistor and place it in the ice bucket as such, and covering it. Going back to the program, we note the values over there. Once the current value has stabilized to within 2 to 3 points, we can click Set Current Value to Standard Value. Now we must calibrate the thermistor for a standard value of 100 degrees Celsius. For this, we use the steam generator. And once the steam generator has reached a temperature of about 100 degrees Celsius, which can be seen from the electronic thermometer, we can use it to calibrate it to 100 degrees Celsius for the thermistor. Now, to do this, first wear the heat-resistant gloves and gently open the steam generator. Because we will need to calibrate it to 100 degrees Celsius, we'll first switch off the steam generator to avoid any bubbles being formed in the steam generator. We then take the stand setup and take the thermistor while dipping it into this hot water or the steam generator. After the thermistor has been put into the boiling water of the steam generator and the current value has been stabilized, we can set the current value to standard value of 100 degrees Celsius. It should be noted that at the standard value of 100 degrees Celsius, the current value is not very stable. This is partially due to the bubbles being formed in the steam generator, which cause fluctuations in the reading. After the thermistor has been calibrated to a standard value of 100 degrees Celsius, we can then take the thermistor out of the steam generator and once again close this generator while turning it on. Once the thermistor has been calibrated, we can now use our first tube to conduct the experiment. To place the tube onto the stand, follow the instructions that you followed when you were measuring the length of the tube. You place the retaining clip on one side of the stand as such. You then take this clip on the bottom side of the stand and put it around the tube such that to secure it. Once the tube has been secured, we can then take the thermistor and put it into the clips. As such. So as you can see, the spring holds the tube in place, while this clip has a thermistor under it. Once our first metal tube has been placed into the stands, we can place the insulation cover on top of the tube, as such. The one going the long way, and the shorter insulation going in the front. Now we are ready to put steam into the tube. Before that though, we must ensure that there is a petri dish under this side of the tube to make sure that all the condensed steam is collected without spilling any water. Then we go onto our computer and we start recording the data by pressing capture. It should be noted that this data should be recorded before steam is put into the tubes. To put steam into the tube, wear your heat-resistant gloves and then take the exhaust from the steam generator and put it into this side of the pipe. you will see water dripping out and this tube expanding. When the tube is no longer expanding, go back to the data collection and press stop. Once the data collection has ended, remove the steam pipe and put it back into the beaker, while then removing also the insulation pipes. And remove the thermistor. Now you should wait a few minutes to let one of the tubes cool down before you change the tubes to repeat the experiment with the other tubes. Once you are done with your experiment with the 3 tubes, you must save your data. To do this, go to File, Export Data, change the .txt option to .csv, and save your file under a name in your USB stick. After you have saved your data, you may now shut off the steam generator and the Pasco 850 unit. Now we move on to the second part of the experiment, which is to get the density of the 2 metals and to make any observations to help us identify what the 2 metals might be. To start off, take the graduated cylinder and fill it to about halfway with water. Now we take one of the 2 metals and we have to measure its mass. To do that, we take a weighing boat, place it on the weighing scale. Remember to zero the scale after you've put the weighing boat on. Now we measure the mass of the metal. Once you have measured the mass of your unknown metal, carefully put it into the graduated cylinder which has the water filled, and make sure that no water spills out. Carefully read the new volume of the water and record it in your data sheet. Repeat these steps for the second metal to find its density.